Have you ever wondered how a computer can solve problems that would take a regular computer thousands of years? Imagine a quantum computer tackling complex calculations in just seconds. Today, let's dive into the exciting world of quantum computing and see if it's finally here. When people hear quantum, they often think of science fiction or something super abstract. But it's not all that wild. Quantum computing is actually a real thing, and it's changing how we think about computers. Imagine being able to solve problems that would take regular computers thousands of years to figure out. Sounds cool, right? So, what exactly makes quantum computers special? Unlike regular computers that use bits, which are just zeros and ones, quantum computers use something called qubits. These qubits can be both 0 and 1 at the same time. This weird trick allows them to process a ton more information at once. Have you ever thought about how that works? It's like having a magic box that can do many things all at once. In 2019, the world of technology witnessed a major breakthrough in quantum computing. Researchers at Google announced they had achieved quantum supremacy. This means they proved that a quantum computer could perform a specific task faster than the best classical computers available. The task involved running a complex algorithm on a prototype quantum computer, which they called Sycamore. In just 200 seconds, Sycamore solved a problem that would have taken the world's largest supercomputer about 10,000 years to complete. This was a significant milestone and showed that quantum computers could potentially outperform traditional computers for certain tasks. To understand why this is such a big deal, it helps to look at how classical computers work. Classical computers use bits as the smallest unit of data, represented as zeros and ones. In contrast, quantum computers use qubits, which can exist in multiple states at once due to a property called superposition. This allows them to process vast amounts of data simultaneously, giving them a massive advantage for certain calculations. The 2019 experiment showcased this unique ability, demonstrating that quantum computers are not just theoretical concepts. They can actually deliver results much faster than previously thought possible. After the announcement, the excitement around quantum computing skyrocketed. Many tech companies and research institutions began investing heavily into quantum technology. For example, IBM, Microsoft, and various startups joined the race to develop quantum systems and algorithms. In 2020 alone, funding for quantum computing initiatives reached nearly $1 billion globally, highlighting the growing interest in harnessing this powerful technology for real-world applications. Researchers quickly recognized the potential uses of quantum computing beyond just speed. Areas such as drug discovery, financial modeling, and optimization problems could greatly benefit from this technology. For instance, in pharmaceuticals, quantum computers could simulate molecular interactions much faster than traditional methods, potentially leading to quicker drug development. This could have a significant impact on healthcare and the fight against diseases. Since that groundbreaking moment, researchers have continued to refine quantum computing technologies. Progress has been made in increasing the number of qubits in quantum systems and improving their stability. As of 2024, several quantum computers are being developed with hundreds of qubits, making them more practical for solving complex problems. The journey from that 2019 breakthrough has been remarkable, paving the way for a new era in computing that holds immense promise for the future. Let's talk about what makes these quantum computers tick. Qubits. These little guys are the key players, but how are they made? Researchers create qubits by placing aluminum on silicon in a specific pattern. This pattern helps create the qubits, which are then carefully handled in a super clean environment to avoid any interference. Why is this important? Because even tiny disturbances can mess up the signals these qubits send and receive. Isn't it fascinating how much care goes into making something so small? It's like crafting a tiny piece of magic. Quantum computers need to be extremely cold because they rely on a phenomenon known as superconductivity. Superconductivity allows certain materials to conduct electricity without any resistance, but this only occurs at very low temperatures. For most quantum systems, temperatures need to be close to absolute zero, which is around negative 273.15 degrees Celsius or negative 459.67 degrees Fahrenheit. At these temperatures, the properties of the materials used in quantum processors become stable enough to allow for effective qubit operations. To achieve such low temperatures, researchers use machines called dilution refrigerators. These sophisticated devices have multiple cooling stages, each one getting progressively colder. For example, the top part of the refrigerator might start at room temperature, while the lower layers can reach temperatures as low as 10 millikelvins, which is only a fraction above absolute zero. The actual quantum processor is placed at the bottom, where it experiences the coldest conditions. This environment is crucial for maintaining the qubit's quantum states and ensuring they can function correctly without interference. The need for such extreme cold is not just about performance, it's also about stability. At higher temperatures, qubits can easily lose their quantum properties due to thermal noise. This loss of coherence is a significant challenge in quantum computing. By keeping the qubits in these supercooled environments, researchers can minimize this thermal noise and enhance the reliability of quantum operations. In recent years, advances in dilution refrigeration technology have made it easier to maintain these low temperatures, which is a vital step in developing more practical and scalable quantum computers. Now that the qubits are made and cooled, they need to be connected and controlled. This is where things get really interesting. A lot of wiring and special electronics help communicate with qubits. These wires are so thin that they are about a quarter the width of a human hair. Imagine threading those tiny wires. Sounds tricky, right? It takes a steady hand and a lot of patience. Why do they need different signals? To make qubits work effectively, researchers must send specific signals to control their operations. These signals are crucial for setting the states of the qubits and enabling them to perform complex calculations. Each qubit needs to be manipulated precisely, just like each musician in an orchestra must play their part at the right time. Even if one qubit is out of sync, the entire computation can fail. This coordination is key to achieving accurate results in quantum computing. The signals used for controlling qubits vary depending on the type of operation being performed. For example, microwave pulses can be used to manipulate the qubits, changing their states from 0 to 1, or placing them in superposition. Researchers have developed various types of quantum gates, basic building blocks of quantum circuits, each requiring different signal patterns. Accurate timing and waveform shape are critical, as any deviation can lead to errors in calculations. In fact, studies have shown that the fidelity or accuracy of quantum operations can drop significantly if the control signals are not perfectly calibrated. As quantum technology advances, the demand for sophisticated signal control systems grows. Researchers are focused on improving these systems to enhance quantum computer performance. Better signal processing leads to faster, more accurate control of qubits, increasing the potential for complex computations. This opens new possibilities in fields like cryptography and optimization. In medicine, quantum computers could speed up drug discovery by simulating molecular interactions much faster than traditional computers. This capability could transform healthcare and lead to quicker development of new treatments. In materials science, quantum computing can help researchers understand the properties of new materials at an atomic level. By simulating how different materials behave, scientists can design better batteries, more efficient solar panels, and stronger alloys. A study indicated that using quantum computers could accelerate the discovery of new materials by as much as 100 times compared to classical methods. This could pave the way for innovations that enhance technology and sustainability. Artificial intelligence is another area where quantum computing can make a significant impact. Quantum algorithms have the potential to improve machine learning models, enabling them to analyze vast data sets more effectively. For example, quantum computing could enhance optimization problems, which are common in logistics, finance, and data analysis. As researchers continue to refine quantum algorithms, the synergy between AI and quantum computing could lead to breakthroughs that we can only begin to imagine today. Each step forward not only increases the power of quantum computers, but also expands their practical applications in everyday life. What could this mean for everyday life? Quantum computing has the potential to significantly impact everyday life by enabling faster and more effective solutions to complex problems. In healthcare, for example, quantum computers could revolutionize drug discovery. Traditional methods can take years to develop new medications, but quantum simulations can analyze molecular interactions much more rapidly. Studies suggest that quantum computing could shorten drug development timelines by up to 50%, making it possible to bring essential treatments to market faster and save lives. In addition to healthcare, quantum computing could also enhance cybersecurity. As technology evolves, so do the methods used by cybercriminals. Quantum computers have the ability to crack current encryption methods, but they can also be used to create new, more secure encryption techniques. Quantum key distribution, or QKD, for instance, allows for secure communication by detecting any eavesdropping attempts. Research indicates that QKD can provide unbreakable encryption, which could protect sensitive information such as financial data and personal communications, ensuring privacy in an increasingly digital world. Overall, the advancements in quantum computing could lead to significant improvements in various aspects of daily life, from healthcare to security. So, is quantum computing finally here? The answer is yes, but we're just scratching the surface. There's still a lot to learn and discover. Exciting times are ahead in the world of technology. Thanks for tuning in. If you found this video interesting, don't forget to like, share, and subscribe for more amazing content. What are your thoughts on quantum computing? Do you think it'll change the world? Let's discuss in the comments below.